So repetition structures, these are our loops. And you can do while loops, do while loops, for each loops. Each one serves a slightly different purpose. For loops are great for arrays because you know the length of the array. And they work really well when you know how many times you want to go through the loop. So whether you are, looping through an array or you know exactly how many times you need to go through, the for loop is probably the best choice. And with a for loop, you have, some kind of a counter. You are going to be initializing to either 0 or 1. And you're going to check that against the number of times you want to go through the loop. Okay. And then each time through, you're going to increment that counter. And that's kind of how it works. And so in this first example, the developer is determining the number of times to go through the loop. Okay. And so if we start at 1 and we want to do less than 11, it's going to end up going through 10 times. Here is another example where we're letting the user determine how many times they want to do the loop. So how many items would you like to buy? We read that in, and then we start at 0, and we're going to go through this loop as long as it is less than the number of items than they specified. And then each time through, we're going to add 1. Okay, so we've got our little loop here, and it's pretty well self-contained. Okay, and so if they wanted to go through 5 times, it is going to go through it 5 times. Now, the off by 1 error happens when it's basically an initializing problem. So if you initialize something to 0, like I did here, then you want to say less than. If you initialize it to 1, then it needs to be less than or equal to. So let me show you how this is going to work. So if I said, let's say they wanted to, the number of items they wanted was 4, okay? And I set I equal to, let's say I set it equal to 1 instead of 0, all right? So first time through, I've got 1 is less than 4. That's true. Go through here now. Is 2. Is 2 less than 4? Yes, it is. Come up here. I is 3. 3 less than 4? Yep. Coming through, it adds 1. Is 4 less than 4? No. So what happened was it only goes through 3 times. So if I set I to 1, then I need to have I is less than or equal to the items. And then it'll go through that 4th time. Okay, and that's the off by 1 error. It deals with how you're initializing and then the condition that you're checking. Okay, so here's the problem. I've got it set to 0 and I'm doing less than or equal to, so it's going to go through 1 too many times. So here's the correction. And here I'm setting it to 1, just like the example we just looked at. And I've got less than, so it's going 1 too few times. So here's the correction. Okay, and this little program you guys could actually copy and play around with and see how that works. The way that it is right now, it is not going to run enough times. Okay, because I've set this to 1 and I've got less than 5. So I would have to say less than or equal to 5. Well, here, I'll go ahead and run it. Okay, so you see it only ran 4 times. So there's actually 2 different ways I can fix this. I can change this to 0. That'll fix it. Okay, and it ran 5 times. Or I could do less than or equal to, and that will also fix it. So it's a matter of, what you're checking for the condition and what you are setting that counter to. So while loops are probably more popular than for loops. They're a little simpler because you're just testing a condition. The important thing that you have to remember when you're setting this up is that above the while loop, you have to initialize that test condition. And then at the bottom of the loop, you have to adjust the test condition. If you never adjust the test condition, it will never test false, which means you are in an infinite loop. Okay. So here's a little example. Here's another one where I've got x set to 0, x is less than size, and you can see I'm increasing x each time. This one, they are entering a number, and if they want to end, they have to enter a -1. So as long as the number doesn't equal -1, we're going to stay in the loop. Okay, and then you'll notice at the bottom, we're reading in the number. So we read in the number here above the while loop, and we also read it in at the bottom. Okay, so here we're checking a counter. And down here, we are incrementing the counter. So you can see we're setting it to 0 here. We're checking it, and here we are incrementing it. Okay, this is critical. If we forget to change the counter, this loop will never end. A lot of times we will use while loops for error handling, like if they've entered the wrong input. So you'll notice that, we have them enter something, we check, we display an error message, and we read it in again. They are not going to get out of this loop until, the condition tests false. And a lot of these loops are interchangeable. So this little section just shows you, well, if you wanted to convert a for loop into a while loop, how would you do that? The for loop has all the little components, as parameters. So you basically have to kind of disassemble the for loop to create the while loop. So you'll notice that the counter is now above the loop. We have to check the condition, and then incrementing the counter is moved to the bottom. Okay. So how would we take this one and convert it into a for loop? Well, we would take our counter initialization, stick it at the beginning of the for loop, and then we would have to take changing the counter and stick it to the end. And that is exactly what we did. Now we said by default, our programs run from top to bottom. And you can kind of change that top to bottom control using repetition and using selection. And you can actually nest those structures, which means here we have a for loop. Inside the for loop, we have an if else. Actually, inside an if else, you can put another loop. Okay, so you can nest these structures. And that basically makes the program perform the way you want it to. When we were looking at the switch statement up in our selection section, we saw the break command. And what the break command does is it kind of takes you out of the structure to the line that is below the structure. There is another command called continue that will alter the flow of the program. And continue is used in loops. And what continue does is it skips all of the statements that are below it, and it goes back to the top of the loop. So continue is kind of like a skip over. So that's how you could look at it. So here is a little example. We want to write even numbers to the console. All right. And to figure out if the numbers are even, we're using the modulus, and we're dividing the number by 2. So if you remember, the modulus shows us what the remainder is in an integer division. So if we have a number, like 9, and we divide it by 2, there is a remainder, so we know it's an odd number. If we have a number like 8 and we divide it by 2, then the result is 0, so we know it's an even number. Okay, so we're checking to see, whether or not we have a remainder. So if we do have a remainder, then it's not going to be equal to 0, and we have a continue, which means that it's not going to write to the console. It's going to go back up to the top of the while loop and start again. So that is what continue does. Okay, so we start out with x equal to 0. 0 is less than 8, so we get into our loop. We add 1, so now x is a 1. 1 divided by 2, or 1 modulus 2, doesn't equal 0. Well, that is true, right? 1 divided by 2 has something left over. It's not equal to 0, so we go back up here. Okay, and now we add 2x, so now it's a 2. 2 modulus 2. Well, does that have a remainder? No, it does not. So we write it out. We go back up to the top. Now we're on number 3. 3 modulus 2 doesn't equal 0. That is true. So we skip this line and we go back up to the top. Okay, so that is what continue does. Anything that's below, it skips. And you saw break in the switch. You can use break in a while loop as well. Anytime you use break, what happens is it goes to the line before. Anytime you see continue, it goes to the top. And I can see my spacing got messed up here, so hold on a second. Okay, that's so much better. So what this little program is doing is once we've gotten to 20, we're done. Okay, and so it's breaking out. And while the counter, is less than 20, we're basically just going to print out even numbers. Okay, so so it's using the modulus again, and it's going to do continue, so it'll just go up to the top. Okay, once we hit 20, it's done. and it stops. Okay, so even though I entered a number bigger than 20, so it's directing them to enter a number less than 20, but I entered a 50 here. Okay, so even though I entered a 50, the maximum number of times is 20. Okay, and you can see I entered the 50 and that was my output.